Hello dear students. Thanks to all for watching my lecture. Today I am talking about good topics. Physics first paper, chapter 4, Newtonian mechanics. The topic's name is moment of inertia. I think that this is really very important part of this chapter. Okay, my dear students, already I will discuss the basics rules of moment of inertia, how we find the moment of inertia for different shape of the object by integrating method. If you do not see the video, then please see this basic lecture, then see this lecture. Okay, now I will today I will discuss two law. One is parallel axis theorem and perpendicular axis theorem. In my previous lecture already I discussed perpendicular axis theorem. Let I also give you some example of perpendicular axis theorem, and then I will discuss parallel axis theorems. I think that this two theorem is really very important for you. Okay, our topics is perpendicular axis theorem. Our topics is perpendicular axis theorem. My dear students, in case of applying perpendicular axis theorems, always try to remember you must have to draw two perpendicular axes. Suppose in case of circular disc, suppose this is a circular disc. Okay, let's we draw two perpendicular. Suppose this is a perpendicular and this is also a perpendicular. Suppose this is x-axis and this is y-axis. This is x-axis and this is y-axis. Okay, my dear students, in my previous lecture already we learned, in case of the circular disc, if this is the normal, if this is normal, in case of the normal, and if this circular disc rotate around this axis, and if this is the radius and m is a mass, then moment of inertia will be mr square divided 2. In our previous lecture already we learned. Okay, already we learned. Now in case of the circular disc, we just try to find out moment of inertia in the rotational axis passing through the diameter of the circular disc. In these cases, how we can find this? Already we draw two perpendicular axis, axis 1 and axis 2. Okay, if you see this diagram very attentionally, then you see that the x-axis divide the circle to equal part and both sides are uniform. Because of the uniform shape of the object, the both sides, the x-axis divide the circle two part. The upper part, this is the lower part. Both two parts are equal to each other. And if you see the picture, y-axis also divide the circle into two equal parts. Because of that reason, this x-axis and this x-axis divide the circle equal part. Because of that reason, moment of inertia in case of x-axis and in case of y-axis will be same. Okay, because of dividing the two axes, the circle equal part. Because of that reason, moment of inertia in case of the x-axis if I, then moment of inertia in case of I, y also I, same. Why the moment of inertia is same for x-axis and y-axis? Because this x-axis and y-axis divide the circle to equal part. Because of that reason, moment of inertia will be same for both axes. Okay, now as these two axes perpendicular to each other, and if we sum moment of inertia x and plus moment of inertia y, then we get another perpendicular axis. Which is the another perpendicular axis? This my pen represent this perpendicular axis. Suppose my pen, this is my marker, and if this is the x-axis and this is the y-axis, and this marker perpendicular with x-axis and perpendicular with y-axis. Okay, if this circle rotate around this axis, this marker represent the z-axis, and if the circle rotate around z-axis, then moment of inertia will be Iz, because this is also a perpendicular axis. This marker represent the z-axis, and this z-axis passing through the intersect of x-axis and y-axis. Okay, the perpendicular axis theorems mean that the summation of the two perpendicular summation of moment of inertia of two perpendicular axes is equal to the moment of inertia that is passing through the intersect point of these two axes and perpendicular with both axes is equal. Okay, this is the notation. Now, as this is the 2D surface, and we cannot draw the 3D diagram here, so this axis is this is the z axis. One side is upward and another is down. This is the z axis. So moment of inertia in case of z axis will be, already we learned in our first diagram. This is the diagram, this is the normal, and here we see this is the surface and z axis is the perpendicular on the circles. Because of that reason, the name of the z axis is normal. Already we learn moment of inertia in case of the normal m r square divided 2. So we can put here the value m r square divided 2, here value of ix I, value of iy also I. So m r square divided 2 is equal to 2i. Here after solving I to transfer m r square divided 4. My dear student, I think that all of you clearly understand. This is the moment of inertia. Okay, this is the moment of inertia in case of the normal. Okay, now I summarize what is happening here actually. If this is the circular disc, uniform circular disc, and this is also uniform circular disc. If this is the rotational axis, and this rotational axis represent x prime, and around this the axis the disc is rotate. Okay, and this is also a rotational axis, and this, suppose this is a rotational axis x prime. If this circle rotate around this axis, here if you see the diagram, then you find a difference here. What is the difference? That the disc is same, the mass and radius. Suppose the mass is m and r is the radius of the disc. Okay, radius of the disc. Both discs mass is equal and radius also equal. What is difference here? The difference here is the rotational axis. You just see very deeply and clearly understand that this is the diameter and this is the normal axis. Both axes passing through the center of the gravity. This is also passing center of the gravity, and this is also passing center of the gravity. But this, if you notice that this is the surface of the disc, and this is the perpendicular. This perpendicular name is normal. So as we cannot draw this axis here, if this is the rotational axis and this disc rotate around this axis. Okay, as we cannot draw this diagram here, so we draw by this way. Okay, my dear student, so this name of this rotational axis is normal. According to the normal, if the rotational axis of a circular disc is a normal and passing through the center, then moment of inertia will be I is equal to m r square divided 2. But in case of the diameter, if the rotational axis is the diameter of a circular disc, then moment of inertia will be I is equal to mr square divided 4. I think that all of you clearly understand. If you understand this part, then I will go the next topics. Okay, I think that all of you clearly understand. So my dear students, always try to understand what is actually happened. I think that all of you clearly understand. Let we go the next lecture. Okay, next topics. My next topics is parallel axis theorem. Parallel axis theorem is really very interesting theorem and very important theorem of moment of inertia for calculating any kind of the parallel axis. Okay, for different shape of the object. Suppose at first we write the name. The topic's name is parallel axis theorem. Parallel axis theorem. This theorem is really very important. What is this theorem? Suppose here has a sun. This is the sun. All of we know that this is the earth. We draw the sun big. This is sun and this is earth. Okay, this is earth. All of you know that the earth is rotate around the sun, centering the sun. Okay, the rotational path of the earth will be this, like this. This is the rotational path of the earth. Okay, this is the rotational path. We know in our previous lecture the basic definition of the moment of inertia. If this is the particle and if this is x prime is a rotational axis, and this is, if this is the point mass, and if this point mass rotate around the axis, and if the perpendicular distance between mass and the rotational axis is r, then moment of inertia I will be mr square divided mr square. This is the basic formula for find out the moment of inertia of a particle. Suppose this is the mass of the particle and this is the rotational axis x prime, and perpendicular distance between the mass and the rotational axis is r. Okay, so moment of inertia will be I is equal to mr square. According to the definition of the moment of inertia, the product of the mass of the rotational rotational particle, the product of mass of rotational particle and square perpendicular distance between the particle and the rotational axis is called moment of inertia. My dear student, you know that if this is the not a particle and if this is the irregular shape of the object and this object rotate around this axis, okay, rotational axis is x prime. My dear student, this is not a particle. This is a object. This is an object. In case of the find out the moment of inertia of an object, that our concern is we at least two way we apply here. One way already we discuss every we know that this object made a lot of the particle, and if this object rotates around x prime axis, that means a lot of the particle actually rotate around this axis. This object has a lot number of the particle. If we find out the moment of inertia every single particle and summation all the moment of inertia of all particle, then we get the moment of inertia of the total object. But another concept is, we know that every rotational axis has a distance where this is the rotational axis, from this rotational axis has a special distance. What is the special distance? Suppose this special distance is k, where all the mass of the object is concentrate. The name of this point is center of the gravity. We know that every object has a center of the gravity where all the mass of the object concentrate on this particular point. So if this object rotate around this axis, then from the rotational axis has a special perpendicular distance from where all the mass of the object is concentrate. And if we consider moment of inertia I mk square, then there is no change moment of inertia. If we make the moment of inertia, if we find out the moment of inertia of every single particle and summation, then we get the total moment of inertia of the whole object. And if we apply this rule and previous rules also give you the same result. Okay, suppose here these two concepts we can apply here. Suppose we know if the earth rotate around this axis centering the sun, if we draw a axis here, this is the CD axis. Okay, the name of this axis CD. But the earth also rotate around its own axis. Suppose the own axis is x prime, and as the earth rotate around its own axis, this is the earth, this earth rotate around its own axis, the radius of the earth is r. The radius of the earth is r. Because of rotational its own axis, here has a moment of inertia. Suppose the name of the moment of inertia Iz. Iz means the moment of inertia of own axis of the solid sphere of earth. This earth like a solid sphere. Okay, because of this reason we can write moment of inertia 2 divided 5 mr square. In our previous lecture already we learned, in case of the solid sphere the moment of inertia will be 2 divided 5 mr square. As this earth rotate around its own axis and also rotating around the sun. Okay, because of rotating its own axis, this earth has a moment of inertia. The name of this moment of inertia Iz is equal to 2 divided 5 mr square. Okay, and again if this earth rotate around the sun centering the CD rotational axis, then here also has a moment of inertia. What is the moment of inertia here? Suppose all the mass concentrate this particular point, as this is the center of the gravity, we can assume all the mass of the earth concentrate on this particular point, and from this rotational axis CD here has a special distance. The name of a special distance is S. So my dear student, here has two types of the moment of inertia. So here also get a moment of inertia, the mass and square perpendicular distance. This is the moment of inertia. Okay, this is also a moment of inertia I. Now if we find the total of moment of inertia, total moment of inertia I is equal to I prime. This is like I prime. Then we summation Iz plus I prime. Iz means Iz, I prime means m h square. This is the equation for find out the moment of inertia parallel axis. As CD is a parallel axis, so from the CD axis we get moment of inertia at first this object for rotational its own axis. As this is rotate around its own axis, so here we can value of Iz. And not only this earth rotate around its own axis, but also this earth also rotate around the sun. Because of that reason here also has a moment of inertia. This moment of inertia represented by I prime, so m h square. This is our basic rules or basic definition. From this basic definition we get this. Okay, if you summation to moment of inertia, then we get the total scenario of the condition of the object. Okay, This is the parallel axis. Actually, this is the parallel axis theorem. What is the parallel axis theorem? At first, we find out the moment of inertia that is passing through the center of the gravity, that we represent Ig. And if this object also rotates around a parallel axis, suppose CD is a parallel of x prime axis, then if we find out the CD axis, then all the mass concentrate on this particular point, that is center of the gravity, and from the CD axis here has a perpendicular distance, name is h. So here also has a moment of inertia, mh square. This is represent I prime. Here also we get a moment of inertia Ig. Here also we get moment of inertia I prime. So if we summation, then we get the total moment of inertia of this object. I think that all of you clearly understand. In my this lecture, I already discussed parallel axis theorem and also perpendicular axis theorem. In my next lecture, I will try to give you some special example by developing some special rules by using parallel axis theorem. Thanks to all.